In this example, a nutritionist is advising someone who's suffering from an iron and vitamin B deficiency, and they want to prescribe at least 2,400 milligrams of iron, 2,100 milligrams of vitamin B1, and 1,500 milligrams of vitamin B2. All right, and there's a couple of different vitamins to choose from, brand A and brand B. So brand A pills cost 6 cents and contain 400 milligrams of iron, 10 milligrams of vitamin B1, 5 milligrams of vitamin B2, and then brand B pills cost 8 cents and per pill and contain 10 milligrams of iron and 15 milligrams each of vitamin B1 and B2. And we want to figure out what combination of pills they should prescribe to this individual to meet the minimum iron and vitamin requirements at the lowest cost. All right, so there's a lot of information here, like I said. There always is. And so, again, I have a table, and let's try to take some of this information and put it in the table to get it organized. All right, so we have two brands, brand A and brand B. And they both contain some iron and vitamin B1 and vitamin B2. So let's just start with that. We can kind of start with the second paragraph. Okay, because the brand A vitamin contains 40 milligrams of iron, 10 milligrams of vitamin B1, and 5 milligrams of B2. And it cost 6 cents. 6 cents per pill. All right. Now, brand B, what do we got for brand B? Brand B contains 10 milligrams of iron and 15 milligrams each of B1 and B2. Okay, so let's fill that in. And the brand B pills cost 8 cents. 8 cents per pill. Okay. Now, the goal here is to meet these minimum requirements. So we want at least, all right? So that means greater than or equal to. We want at least 2,400 milligrams of iron. We want at least, so at least means greater than or equal to 2,100 milligrams of B1. And we want at least 1,500, so at least 1,500 milligrams of B2. Okay? Now, we want to minimize costs, right? Minimizing the cost is our objective function. And we want to figure out how many of each type of pill to prescribe. All right, so let's go through the same process we did for the previous example. The first thing I'm going to do is define my variables. Define the variables. All right, well, because we're trying to figure out how many of each pill to prescribe, we're just going to let that be our the variables. We're going to let X be the number of brand A pills to prescribe, right? And Y will let be the number of brand B. Okay? And then our objective is to minimize cost. Okay, so let's write an objective function. Objective function. Okay. So we want to minimize the cost in this case. All right. So how much are these pills going to cost? Well, it depends on how many we prescribe, right? So if we're going to prescribe X of brand A, and so X is the number of pills. So if I just take 6 times X, I'll get the cost for the brand A pills. And I'm also going to prescribe some brand B pills, and each one of those costs 8 cents. So 8 times Y gives me the cost for the brand B pills, and I want to I want that to be minimized, right? That is my total cost. So I'm going to call this my function, my cost function, C of x, y, where x and y are the inputs, right? So if I'm given an x and I'm given a y, I can calculate a cost, okay? So that's my objective function. And then I want to write my constraint equations, okay? So the constraint equations are just based on meeting those minimum requirements for iron and the B1 and B2, right? So the constraints, let's write the constraints. Okay, we have a constraint on iron. First of all, whoops, iron. All right. And we want to have at least 2,400 milligrams. All right. So, but I know that each brand A pill contains 40 milligrams. So if I take 40 times the number of brand A pills, I'll get the total amount of iron from the brand A pills I'm going to get. And then each brand B pill contains 10 milligrams of iron. So if I take 10 times Y, I'll get the amount of iron I get from the brand B pills. And so I want that to be at least 2,400 milligrams. Okay, so that's my constraint on iron. And then I can just do the same thing for B1 and B2. All right. So I know that there is 10 milligrams of B1 in my brand A pills, so 10 times the number of brand A will give me the total B1 from the brand A. And then 15 milligrams, there are 15 milligrams of B1 in the brand B pills. So if I take 15 times the number of brand B pills, that gives me the amount of B1 in the brand B, and so I want that to be, I want the sum of those two to be at least 2,100 milligrams. Okay, same thing for for vitamin B2, right? Brand A contains 5 milligrams. Brand B contains 15 milligrams. So 5x plus 15y should be at least 1,500 milligrams. All right. And then again, there are some implied constraints because we can't have a negative number of pills. So I'm also going to include the constraints that x has to be greater than or equal to 0 and y has to be greater than or equal to 0. And that's basically it. That's the formulation for my linear programming problem. And that's all we're going to do today is just formulate the problems. All right, we're going to practice formulating these problems. All right. So, because there's, like I said, there's a lot of information, you got to get it organized, and then you have to write equations, all right? And that's sometimes the hardest part. So, in general, this is the procedure for formulating a linear programming problem. We want to, first of all, organize the information. Okay, now I did it with a table in both of the preceding examples, and a table is often a good strategy to use. Now, you may or may not need to make a table depending on the type of problem that you're given. But oftentimes a table is a good thing to use. But you're probably going to have to make your own table if you think a table is necessary for the problems in the WebAssign homework and stuff. So, and then we define our variables. And oftentimes, like I said, a clue to figuring out what the variables should be is given in the question at the end. You know, what are we trying to find? We're trying to find the number. In this case, we were trying to find the number of pills. So it would make sense that we let our variables be the number of pills of each type. And then we write our objective function. All right, that's the thing we're trying to maximize or minimize. And then we write the constraint equations. All right, so that's the general procedure for formulating a linear programming problem. All right, well, there are a couple of discussion questions, which I recommend that you go ahead and look at. Maybe give them a try. Try to set up a table, get them started, and I'll meet you in class to go through them. All right, see you later.